listeners. Welcome to another episode on the Global Mic.
All right, so we're diving deep today into something pretty amazing, making oxygen on the moon.
Yeah.
And this isn't just some sci-fi fantasy. This is real research with some serious potential for future lunar missions and even beyond that.
Absolutely.
But let's be real for a second. Actually doing this is, well, it's going to be tough.
Well, it's a huge challenge.
Yeah, the moon is not exactly the most welcoming environment, right?
Not at all.
Yeah.
But that's what makes it so exciting. We're talking about pushing the boundaries of human ingenuity.
Okay, so let's start with the basics. Why is lunar oxygen production such a big deal? I mean, we know we need it to breathe, but there's got to be more to it than that, right?
Oh, yeah. Way more. Think about it. Right now, everything we need for space missions has to be launched from Earth.
Which is crazy expensive.
And incredibly inefficient. But if we can produce resources like oxygen right there on the moon.
We're talking about a whole new ballgame.
Exactly. It could revolutionize space exploration. Suddenly, the moon becomes a launching pad, a refueling station.
Okay, I'm starting to see the bigger picture here. But how do we actually get oxygen from moon dust? Isn't it just well dust?
Well, it's not just any dust. We call it Lunar Regolith, and it's packed with metal oxides. Things like iron oxide, titanium oxide.
The stuff rust is made of.
Exactly. And those oxides are key to unlocking oxygen.
So we're talking about turning rocks into breathable air. That sounds like alchemy.
It does, doesn't it? But the science behind it is solid. There are two main methods being explored right now: carbothermal reduction and molten regolith electrolysis.
Okay, those are some big words. Break it down for me.
Sure. Carbothermal reduction basically involves heating up the regolith to super high temperatures and adding carbon.
Like coal.
Yeah, similar idea.
Yep.
It triggers a chemical reaction and releases oxygen.
So it's like baking oxygen out of the rocks.
Kind of. And then there's molten regolith electrolysis,
Yeah.
which is even more, intense.
Molten regolith. So we're talking about melting moon rocks.
Exactly. You melt the regolith and pass an electric current through it that splits the oxygen away from the metal oxides.
Molten moon rocks and electricity? What could possibly go wrong?
Well, there are definitely challenges, but that's what engineers and scientists are working on, figuring out how to make these processes work reliably and efficiently on the moon.
And one of the companies tackling this carbothermal approach is Sierra Space, right?
That's right. They're doing some really innovative work, adapting their technology to handle the harsh lunar environment.
Yeah, I've read about that. Apparently, lunar regolith is incredibly abrasive. It can really wear down machinery.
It's like sandpaper on steroids. So Sierra Space has had to come up with some clever solutions, special filters and components that can withstand that constant wear and tear.
From what I've read, they're even experimenting with different types of carbon to use in the process.
Yeah, they're constantly refining their techniques, trying to find the most effective and efficient approach for the moon.
So it's not just about building a machine that can survive on the moon. It's about optimizing every aspect of the process for that unique environment.
Exactly. And that's true for both carbothermal reduction and molten regolith electrolysis.
Speaking of which, didn't we say that low lunar gravity can mess with that process too?
Yeah, it's one of the biggest challenges. It affects the way oxygen bubbles detach from the electrodes during electrolysis.
So it's like trying to make soda fizz in space.
Kind of. But researchers are coming up with some ingenious solutions. Things like using vibrations or specially designed electrodes to help those bubbles detach.
Okay, so we've got these two main methods, carbothermal reduction and molten regolith electrolysis, both with their own unique challenges. But why are we so focused on making oxygen on the moon in the first place?
Well, for one thing, it's essential for life support. Astronauts need to breathe.
Right, of course. But I have a feeling that's not the whole story.
Nope. The real game changer is the potential for rocket fuel.
Wait, really?
Yeah, oxygen is a key component of rocket fuel. And if we can produce it on the moon, it could drastically reduce the cost and complexity of launching missions from there.
So instead of hauling fuel all the way from Earth?
We could just gas up on the moon.
So the moon could become like a cosmic gas station.
Exactly. Launching pad for missions deeper into space. Maybe even to Mars.
That's pretty mind-blowing when you think about it.
It is, and it's a great example of why this research is so important. We're not just talking about surviving on the moon, we're talking about using it as a stepping stone to explore the rest of the solar system.
And all this without having to ship tons of oxygen from Earth.
Imagine the cost savings and logistical advantages. It's about making space exploration much more sustainable in the long run.
So how much regolith are we talking about here to produce a usable amount of oxygen? I mean, are we going to have to strip mine the entire moon?
Not at all. Actually, Dr. Burke has estimated that an astronaut would only need the oxygen equivalent of about 2 to 3 kilograms of regolith per day.
That's not that much.
Nope. And in a future lunar base, life support systems would likely recycle a lot of the exhaled oxygen.
So we're not talking about massive mining operations just to keep a few astronauts breathing.
Exactly. It's a much more manageable proposition than you might think.
But it's not just about oxygen, right? Lunar regolith is also a source of other valuable materials.
Absolutely. It contains metals like iron, titanium, lithium, all essential for building structures, creating tools, and manufacturing parts.
So instead of shipping everything from Earth,
We could use lunar resources to build and maintain our lunar bases and spacecraft.
that's incredible. But how do we go about turning regolith into usable building materials? It's not like you can just stack moon dust and expect it to hold up.
Well, that's where things get really interesting. Researchers are exploring a variety of methods, from sintering, where you heat and compress the regolith, to 3D printing with regolith-based materials.
Wait, 3D printing on the moon?
It's closer than you might think. There are already companies developing 3D printers specifically for lunar construction. Imagine printing entire habitats or landing pads directly from lunar regolith.
Okay, that officially blows my mind. Are there any other crazy ideas out there?
Well, how about this? Palak Patel at MIT has been experimenting with melting regolith and transforming it into super durable glass-like bricks.
Glass bricks from moon dust? What, are they building a lunar crystal palace?
Maybe, who knows? But the point is we can turn this seemingly simple material into a variety of useful products.
So we're talking about a future where lunar settlements are built with locally sourced materials powered by the sun and producing their own breathable air and rocket fuel.
It's a pretty amazing vision.
Mm-hmm.
And it all starts with understanding the potential of lunar regolith.
It sounds like we're on the verge of a new era of space exploration, one where the moon plays a central role as a resource-rich hub for our expansion into the cosmos.
It's an incredibly exciting time to be following these developments.
But as with any new frontier, there are bound to be challenges along the way, right?
Oh, absolutely. Technical hurdles to overcome, and we need to make sure we develop these technologies in a responsible and sustainable way.
Well, let's dive into those challenges and see what brilliant minds are coming up with to overcome them, shall we? So we've talked about how amazing lunar regolith is, but turning that potential into something we can actually use on the moon, that's got to be a whole other story.
Yeah, it's one thing to do this in a lab here on Earth. It's another thing entirely to get it working reliably on the moon.
What are some of the biggest challenges they're running into?
Well, the lunar environment is incredibly harsh. You've got extreme temperatures, radiation, and a low gravity. It's a constant headache.
We touched on the low gravity thing earlier, how it can mess with the oxygen bubbles during electrolysis.
Right. But it's not just that low gravity affects everything. Liquids behave differently, powders don't settle the same way, and even simple construction becomes much more complicated.
It's like a whole different set of physics.
Pretty much. And it forces engineers to completely rethink their designs.
So how are they adapting?
Well, take Sierra Space, for example. They've been working on this carbothermal reduction method, and they've had to redesign their reactor to withstand the abrasive nature of lunar regolith.
We keep saying abrasive, but just how bad is it?
It's really bad. Those tiny particles of regolith can wear down machinery incredibly quickly. Think of it like sandblasting every moving part constantly.
Wow, so their equipment is basically getting sandblasted 24/7.
Yeah, so Sierra Space has had to develop special filters and components that can handle that constant wear and tear.
It sounds like they're really pushing the limits of material science.
They are. And they're also experimenting with different types of carbon to use in the process, because some forms are more effective than others in the lunar environment.
It's like every single aspect has to be optimized for the moon.
Exactly. And it's not just Sierra Space. The teams working on Molten Regolith electrolysis are dealing with their own set of low-gravity problems.
Yeah, we talked about the bubble issue earlier. What else is giving them trouble?
Well, containment is a big one on Earth. Gravity helps keep molten material in place, but in low gravity, it tends to spread out and behave in unpredictable ways.
So it's like trying to pour molten lava in space.
Kinda, but not quite that dramatic. Still, designing a containment system that works reliably on the moon has been a real challenge.
Are there any solutions on the horizon?
There are some promising ideas out there. Some teams are looking at using magnetic fields to contain the molten regolith, while others are experimenting with special crucible designs that take low gravity into account.
Magnetic fields, that's pretty cool.
It is, and it shows the kind of creative thinking that's required for lunar engineering.
Okay, so we've talked about the challenges of low gravity and the abrasive regolith, but there's another big one, energy. All these processes, whether it's carbothermal reduction or electrolysis, require a lot of power. How are we going to power all of this on the moon?
That's a key question.
Mm.
Right now, the most viable option seems to be solar power. The moon has long periods of daylight, which we could use to generate electricity.
So giant solar panels on the moon?
Basically.
Hmm.
But there's a catch. Lunar night lasts about 14 Earth days, and during that time, there's no sunlight.
So we'd need a way to store that energy.
Exactly. We'd need some serious energy storage solutions, like advanced batteries or fuel cells, to keep everything running during those long lunar nights.
And what about nuclear power? I've seen some articles about using nuclear reactors on the moon.
Nuclear power is definitely an option. It could provide a reliable and long-term energy source for a lunar base.
Yeah.
But there are obviously safety concerns and logistical challenges to consider.
Like transporting nuclear material to the moon.
Exactly. It's a complex issue with no easy answers.
It really highlights the fact that we're not just talking about extracting oxygen, we're talking about building a complete sustainable infrastructure on the moon.
Absolutely. It's about creating an entire ecosystem where we can generate power, produce vital resources, and ultimately establish a permanent human presence.
So who's going to be running all this equipment on the moon? Are we talking about sending teams of astronauts to become lunar miners?
Well, human presence will always be important, especially in the early stages. But I think the future of lunar manufacturing is going to be a lot more automated.
Robots.
Yeah, robots are perfect for this kind of work. They don't need to breathe, they can handle extreme temperatures, and they're immune to radiation. Plus, they can work around the clock without breaks.
But can robots really handle the complexity of these processes?
That's where AI and machine learning come in. We're already seeing robots that can learn and adapt to new situations, solve problems, and even repair themselves.
Self-repairing robots on the moon, that's wild.
It is, and it's essential for making lunar operations more efficient and less reliant on humans.
This is all starting to sound like science fiction robots mining the moon, 3D printers, building habitats, everything powered by the sun.
It's an exciting time to be alive, that's for sure.
Yeah.
But let's not get ahead of ourselves. There are still plenty of challenges to overcome.
Right, we've talked about the technical stuff, but what about the bigger picture? How do we make sure we're doing all of this responsibly and sustainably?
That's a crucial question we need to learn from our mistakes on Earth and make sure we're not repeating them on the moon.
So we're not just going to treat the moon as another resource to exploit.
Absolutely. We need to develop a set of ethical guidelines for lunar development, prioritizing sustainability, minimizing waste, and making sure the benefits are shared equitably.
Makes sense. We don't want to turn the moon into a cosmic wasteland.
It's about finding a balance between exploration and preservation.
Well, it sounds like there's a lot to consider, both the technical challenges and the ethical ones.
There is, but I'm optimistic. I think we have the ingenuity and the will to make this work.
I like your optimism. It's contagious.
Yeah.
You know, this whole conversation has really got me thinking about the concept of a lunar circular economy.
That's a great topic and one that's gaining a lot of traction in the space community.
Well, let's unpack that in our final segment, shall we?
Let's do it.
All right, so this lunar circular economy thing, it sounds kind of like we're trying to create a closed-loop system on the moon.
Yeah, that's the basic idea, minimizing waste and maximizing resource utilization.
So instead of constantly shipping new stuff from Earth...
We create a system where everything gets repurposed and reused as much as possible.
Okay, so it's like the ultimate recycling program.
Exactly. And it goes beyond just physical materials. Think about using the byproducts of oxygen production.
You mean like the carbon monoxide?
Yeah, we could use that as feedstock for other processes, or use wastewater from a lunar habitat to grow algae.
And then use that algae for?
Food or biofuel. The possibilities are pretty amazing.
So we're talking about creating a whole interconnected system where every output becomes an input for something else.
Exactly. It's not just about copying Earth's ecosystems, it's about engineering entirely new ones that work specifically for the moon.
That's pretty wild. So what are some of the technologies that are going to make this happen?
Well, the European Space Agency has been doing some great work on closed-loop life support systems for lunar habitats. They're focused on recycling air water, even organic waste.
I read something about microbial fuel cells. What are those?
So microbial fuel cells use bacteria to break down organic waste, things like plant matter, or even human waste, and they generate electricity in the process.
So we're literally turning poop into power.
It's not quite that simple, but yeah, it's a pretty amazing technology. A really efficient and sustainable way to deal with waste and produce energy.
I bet there are going to be a ton of unexpected applications that come out of this lunar circular economy stuff.
Oh, definitely. One area I'm really excited about is biomining, using microbes to extract valuable metals from Regolith.
So instead of digging giant mines,
We could use these tiny little miners to do the work for us.
and it's probably a lot more eco-friendly too.
Exactly. Much less disruptive to the lunar environment.
This is all starting to feel like a whole new approach to resource management, not just for the moon, but maybe even for Earth.
Yeah, I think the lessons we learned from building a circular economy on the moon could have huge implications for how we do things back home.
It's like we're going to space to learn how to save our own planet.
It's kind of ironic, isn't it? But it makes sense when you think about it. The challenges of living on the moon force us to be a lot more creative and resourceful.
Okay, so we've talked about the how to extract oxygen, build a lunar base, create a circular economy. But I think it's also important to talk about the why. Why are we doing all of this? What's the big picture?
For me, it comes down to two things: expanding our knowledge and ensuring our survival.
Expanding our knowledge. I get that space exploration has always been about pushing the boundaries of what we know, but ensuring our survival. What do you mean by that?
Well, Earth isn't going to last forever.
Yeah.
At some point, we're going to need to look beyond our own planet to find new resources and new places to live.
So the moon and eventually Mars and beyond become our backup plan.
I wouldn't call it a backup plan so much as an expansion plan. It's about diversifying our options and creating new opportunities for growth and discovery.
Becoming a multiplanetary species.
Exactly. And all of this work we're doing on the moon is laying the foundation for that future.
It's pretty incredible when you think about it. We're taking the first steps towards a permanent human presence beyond Earth.
It's a huge undertaking, but it's also incredibly inspiring.
Well, this whole deep dive has definitely given me a lot to think about.
Me too. It's an amazing time to be following all of this.
I have one last question for you. If we can create a self-sustaining presence on the moon using local resources and all these crazy new technologies, could we apply those same principles to solve some of our biggest problems here on Earth?
That's a great question. And I think the answer is yes. The challenges of living on the moon force us to think differently about resource management, waste reduction, energy production, and I think those solutions could have a real impact back on Earth.
So the moon isn't just a stepping stone to the stars, it's also a mirror reflecting back at us new ways of solving our own problems.
I like that analogy. It's about looking outward to learn how to better care for our own home.
Well said. So to our listener out there, if we can crack the code on the moon, imagine what else might become possible. Keep looking up, keep asking questions, and never stop exploring.
All right, listeners, see you next time. Have a nice day.